If you're an Android developer, you know that navigation is so much more than just getting from screen A to screen B, right? It's really the backbone of your app's entire architecture. You've got to nail this, especially when you're in a system design interview. So let's break it all down. How to build navigation that's totally leak-free, super scalable, and will help you ace that interview.
Okay, let's just get right to the elephant in the room. For years, I think we can all agree Android navigation felt like you were just walking through a minefield of memory leaks. We've all been there, right? Hunting down some mysterious crash for hours. But what was the fundamental flaw that made this so darn difficult for so long?
Well, to really appreciate the new, elegant solution, we have to take a quick trip down a not-so-pleasant memory lane. We've got to revisit the old nightmare. It was manual, it was fragile, and honestly, it almost felt like it was designed to cause problems.
Does any of this sound painfully familiar? Manually committing fragment transactions, fighting with the backstack, trying to wrestle deep links into working. It was, frankly, a mess. And oh man, trying to build clean multi-backstack support for something like a bottom navigation bar? That often meant you were writing a crazy complex, custom solution completely from scratch. And all that complexity, it was just the perfect breeding ground for memory leaks.
Thankfully, Google finally gave us the Jetpack navigation component. And look, this isn't just another library you drop in. It's a complete, fundamental shift in architecture. It was designed from the ground up to help us create apps that are scalable, robust, and, most importantly, leak-free.
So this new architecture really hinges on two key players. First up, we have the nav controller. And the absolute best way to think of it is as the map. It holds your navigation graph, it holds your backstack. It's just pure data about where you can go and where you've been. But here's the crucial part. It holds no references to the actual UI. It's just state.
And if the nav controller is the map, then the nav host fragment is the driver. It's the UI component that actually listens to the map's instructions and does all the heavy lifting. It creates the fragments, it shows them, and this is the most important part, it destroys them. This separation of concerns, well, that's the key to the entire system.
And yeah, that separation, that clean line between the map and the driver, that is the secret sauce for preventing memory leaks. It's such a simple but incredibly powerful design principle. You manage the state, not the UI instances themselves.
All right, so let's get down to the brass tacks. How exactly does this design stop those dreaded memory leaks from ever happening?
This slide just lays it out perfectly. In the bad old days, your long-lived view model might hold a reference to a short-lived fragment. Well, this prevents the fragment from being garbage collected, cleaned up from memory, and bam, you've got a memory leak. But with the new architecture, the view model only talks to the nav controller. And since the nav controller holds zero UI references, that dangerous chain is broken. The nav host fragment can safely destroy the fragment, and the leak is completely avoided.
If you take away just one single thing from all of this, let it be this mantra right here. The nav controller manages navigation state, the data about where you're going. It does not manage the heavy UI instances. That simple, elegant distinction is the entire key to a leak-free architecture.
So let's trace the flow step by step. A user taps a button, right? That triggers a navigation request in the view model. The view model then tells an abstraction layer, we'll call it a navigator, which in turn tells the nav controller to navigate. The nav controller just updates its state, the map, and notifies the nav host fragment. Only then does the nav host fragment, our driver, do the actual UI work. The critical thing to see here is that the fragment instance is never exposed back to the view model. It's a clean, one-way flow of information. Okay, so we've established it's memory safe, which is, that's huge. But what's the real payoff? What other powerful modern patterns does this architecture unlock for us?
Well, one of the biggest payoffs is incredible multi-backstack support. This is absolutely essential for modern apps with bottom navigation. Each tab gets to maintain its own independent history, so when a user is switching between tabs, they don't lose their place. It's totally seamless because the system isn't wastefully destroying and recreating fragments all the time. And hey, quick heads up, interviewers at companies like Meta or TikTok will almost certainly expect you to understand this inside and out.
And here is another massive win: automatic process death restoration. Because the navigation state is managed so cleanly, the system can automatically save it and restore it for you. So even if the Android OS decides to kill your app in the background to save memory, when the user comes back, they're right where they left off. It just works. You don't have to write tons of boilerplate code to handle it anymore.
All right, let's switch gears. how do you actually translate all this knowledge into totally acing your system design interview? Let's whip up a quick cheat sheet with some common questions and the perfect answers.
When you get this question, just stick to that analogy. It's simple and it's powerful. The nav controller is the map. It manages the navigation state and the backstack. The nav host fragment is the driver. It's the UI container that handles the actual fragment lifecycle. Simple as that.
Now this question gets right to the heart of the architecture, and the answer is super simple: to prevent memory leaks. The nav controller's lifecycle is often much longer than an individual fragment's. So if it held a direct reference, it would stop the garbage collector from cleaning up fragments when they're no longer needed.
The key principle to talk about here is decoupling. Your view model shouldn't even know that the nav controller exists. Instead, it just communicates its intent, like, hey, go to the details screen, to a navigator abstraction. That middle layer is what makes the actual call to the nav controller, which makes sure your view model stays completely decoupled from the UI framework.
So to sum it all up, these are really the pillars of a great design. A single activity architecture gives you one central point of control. That navigator abstraction decouples your business logic from your UI. Separating state from instances, as we've seen, prevents memory leaks, and using the nav host fragment ensures proper lifecycle management. This really is the blueprint for a modern, scalable Android app.
And that brings us to one final, really important question to think about. This powerful principle of separating the state of something from the UI that actually renders it, well, it goes way beyond just navigation. So think about it. Where else in your own apps could you apply this pattern to make your code more robust, more testable, and more memory safe? It's a design principle that really pays dividends everywhere you use it.